connected to guest Wi-Fi?
Now it's streaming. What?
Are you connected to the guest Wi-Fi?
Oh. I have no idea. I'm not gonna. If it's not Baroque, don't fix it. Okay. Questions about the homework? Oh, really?
Yeah.
Okay.
Just 43 and 57.
Okay. Excuse me. Okay. 43 says a formula for the derivative of function f is given. How many critical numbers does it have? So 1 plus 210 sine x over x squared minus 6x minus 10 plus 10. Okay, so we just need to set this equal to 0 because this is already the derivative. So negative 1 equals 210 sine x over x squared minus 6x plus 10. Are there children like running past the door? Okay. Very unhappy. What animal does that sound like? Like a raccoon or something? Okay, anyways. So x squared minus 6x plus 10 equals negative 210 sine x. Does that make sense? Okay. Let's see. X minus 5. No, you can't do that. At this point, I think I would just graph them. See where they equal each other. Or you could just honestly graph the original. So 1 plus, oh, yeah, it's in radians. Okay, 210.
The answer somehow is 10, like there are 10 critical numbers. I just don't know how they came up with that.
Let me see. Let me graph these and see what happens. Oh, and it's either cold or hot in this room. So if you want me to adjust the temperature, totally will. But I still have faith that it would be uncomfortable. Okay. That's an ugly beast. Right? Zoom out. It looks like a heartbeat. That's so... Doesn't it?
Yeah.
No, Sam, it does. No, passive. Alright, so we're just going to count how many places it crosses the x-axis, because that's where it equals 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's it. So that's 43. Is that what you did? That's not cheap. I really don't. Oh, my mom hopes my day is going well. She loves me. Okay, so yay. I love her too. I don't know about your people's moms, but mine is better than yours. Okay. So that answers that. I honestly do not know how to algebraically solve that because you can't use the zero product property. It would be very difficult. You'd have to divide by 210 and you couldn't use the quadratic formula because it doesn't equal 0. So I don't know how to solve that personally. Okay, so graphing it is the only way that I would recommend doing that problem. I made her feel good. Okay, so 57. If a and b are positive numbers, find the maximum value of f of x equals x to the a 1 minus x to the b on the interval 0 to 1. Okay. I don't really want to. Okay, so f prime of x equals x to the a times b 1 minus x to the b minus 1 times negative 1 for the chain rule plus 1 minus x to the b a to the x, or a times x to the a minus 1 I don't want to do this. Sorry. 0 equals b x to the a 1 minus x to the b minus 1 negative plus, and it makes sense why it's negative. 1 minus x to the b. So ax to the a minus 1 times 1 minus x to the b equals bx to the a 1 minus x to the b minus 1 That make sense? Okay. So bx to the a 1 minus x to the b minus 1 a over b x to the a minus 2. No. It's a minus 1 minus a. So does this make sense what I'm doing right now? Okay. So that's to the negative 1 minus x. So b minus, so that's just to the first, so I'm just going to leave that off. So that equals a 1 minus x over b x, which equals 1, so minus 1 equals 0. So f prime of c equals a times 1 minus c over bc minus 1. So then say I'm just thinking if I need to plug that into the original function. I don't want to. Sorry. Okay. So want to plug that in. It's awful. Did you get this far?
I didn't do it that way.
Oh, what'd you do?
I factored out the x a minus 1 and the 1 minus x to the b minus 1, and then I got left with negative bx plus a 1 minus x to the b. A 1 minus x.
Wait, you factored out an argument, and then what did you do with it after you factored it out?
Oh, just left it.
Okay.
This is 0 equals, so 0 and 1. And then the third one was the critical number.
The third one?
Yeah, the third. So I factored out x to a minus 1 and then 1 minus x to the b minus 1. So then the 1 and the 0 would be
Hang on.
0.
Oh, I see. Okay, wait.
Yeah.
So you factored out 1 minus x to the b?
B minus 1.
B minus 1?
Yeah.
And then you got
That would
bx?
just make it 1 minus. Yeah. Yeah.
And then you said 0 equals 1 minus x to the b minus 1?
Yeah, I also factored out the x a minus 1.
Okay. So then 0 equals 1 minus x to the b minus 1. So then x equals 1. 0 equals xa to the a minus 1. X equals 0. And then bx plus a minus ax equals 0. There's a third critical number. Is that, you got the same thing?
Yeah, I got a over a plus b. Because the bx is supposed to be negative.
Why?
Because it's negative bx to the a.
Oh, that's little. Good. Good. Then you're going to plug those in. Sorry, I was running through my head about something else. Okay, so f of 0 equals 0. F of 1 equals 0. Dang it, I don't want to do that one, but whatevs. I'm a responsibility. That's hideous. Oh, A and B are positive. Okay. So there it is. So that thing. Insert here. Maximum value at that point. Good. Are you nodding in agreement? Good. Still kind of hungry. All I have is like a salad and an adult Lunchable. Man, adult Lunchables are kind of crappy because, I mean, they're fine, they're nicer food, but it's still the amount of food as a Lunchable, which is enough for a child. So, yeah, they should put an adult amount of food in an adult Lunchable. They don't. It's just really a snack. They're pretty fancy.
Whoa.
Wow. Look at that.
That's a whole meal.
No. That's like the point there. No. I don't know what the intended point is, but the point of my diatribe is that it is not a whole meal. Did you get? I used diatribe in 2 consecutive classes. It's good. I don't use that word that often. The last one was making a joke about critical numbers. Okay, so any other questions on the homework?
Yes.
Okay.
Number
67. Did you think the homework was hard?
Some of it, yeah.
Some of it, yeah. So did you think back to class when I said that it wasn't too hard?
Yeah.
And then we looked over it and I was like, no. Did you think like she was a liar?
Yes.
Dang it, Sam! Okay. When a foreign object lodged in the trachea forces the person to cough, the diaphragm thrusts upward, causing an increase in pressure in the lungs. This is accompanied by a contraction of the trachea. What interesting background information for this problem, right? It can narrow a channel for the expelled air to flow through. For a given amount of air to escape in a fixed time, it must move faster through the narrower channel than the wider one. The greater the velocity of the airstream, the greater the force on the foreign object. X-rays show the radius of the circular tracheal tube. I'm kind of a jerk for the problems I give you.
Yeah.
Yeah. Anyways, have you guys seen Nacho Libre?
Yeah.
Because that's like our favorite line from the movie. When she's like, he comes up to her and he's like, "Sí, sir. I'm Ignacio. God be with you, Ignacio." Anyways. Our favorite part of the movie. Okay, so according to mathematical model of coughing, Man, what some people are into. The velocity v of the airstream is related to the radius by that, where k is a constant, r naught is the normal radius of the trachea. Restriction on r is due to the fact that the tracheal wall stiffens under pressure, and a contracture greater than 1/2 r naught is prevented. Otherwise, the person would suffocate. Determine the value of r in the interval 1/2 r naught r naught. Sorry. At which point v has an absolute maximum. How does this compare with experimental evidence? This is stupid. So the r equals, in a positive way. This is stupid in a positive way. Okay.
Makes sense.
My shirts came yesterday. I ordered them all. I'm super excited. I almost wore one of them today, and then I decided to be more professional. Well, one of them has a cat riding a piece of pizza through space with rainbow lasers coming out of its eye. Have you seen this?
No, but I
Oh, it's pretty cool. I'm not a cat person, but I like that cat. I'm good with it. And then another one says, I used to be cool, because, I cling to that. And then another one says, it was me. I let the dogs out.
That's awesome.
And then my favorite, well, another one has a cactus with a really sad face, and he says, hugs. And it's sad. And then my favorite has a picture of Martin Luther. You know Martin Luther?
Yeah.
Have you guys taken world history or AP or something like that?
Yeah.
Martin Luther. What's he known for?
Yeah.
What did he do to him?
Nailed him on a cord.
Yes. So my shirt has a picture of Martin Luther, and then it says, nailed it.
Oh my gosh.
I've been waiting for it to come. So funny. It's funnier than the Electron shirt. Right? Yeah, it is. Okay. V of r equals k times r naught minus r squared. 1/2 r naught. R naught is less than r is less than r naught. Okay. V prime of r equals, k is a constant, right? Okay. So you have 2r, r naught minus r, plus r squared, negative 1. So 2r, r naught minus r squared. So far, so good? Good. 0 equals. Factor out a negative r. We get r minus 2 r naught minus r. Were you going to say something?
No.
Okay.
Well, actually, though, wouldn't the derivative of r naught minus r be 0?
No.
Because 1 minus 1.
No. Because the derivative of r naught is 0. Because r naught is a number. And then minus 1. So, sorry, I just can't get it. There it goes. I got it. Okay. Which equals negative r times, and this became negative 2r naught plus r. So 2r minus 2r naught. So r must be equal to, oh, hang on. I want to do that instead, just so that I'm r minus r naught. So equals 0. R equals 0 or r naught. Good. What does it want? Determine the value in the interval there at which v has an absolute maximum. So it has to be r naught because 0 is not in the interval.
It looks as 2/3 r naught.
Whatevs. I'm so tired of the book. Anyways. Okay, determine the value of R in a mineral. Did you get this for the derivative too? Oh, you must not have if you said that it was 0. Oh, I left out K. Let me do the derivative again. Okay. In purple. Okay. So, B prime of R. I'm going to write this as R, K, R squared. Okay. So, 2KR, R naught minus R, plus negative 1 times KR squared, which equals 2KR, R naught minus R, minus KR squared. I don't think this is going to impact it too much. I really just want to get to a critical number and then have factor out negative KR, and that's going to be R minus 2R naught plus 2R equals 0, negative KR, 3R minus, oh, that's why it's 2/3. And the K did impact it. Yay! Does that make sense?
Yeah.
Cool. Did you want me to do B and C? Because I will.
Yes.
Dang it! So, what is the absolute maximum value of V on the interval? Okay, so, don't even worry about the how does this compare with experimental evidence. I don't care. Okay. Okay. Were you worried about it?
Well, I mean, at that point, it wouldn't be too difficult because they said in the radius of the circular trig of the tube contracts to about 2/3 of its normal radius. So you just kind of connect those two.
And be like, yeah.
Yeah, mathematically.
Yeah, but that's a bunch of words, so you don't need to write them if you don't want to. That's what I mean. Okay.
I just put an arrow and it said supports statement. So.
Okay. I will accept that. That sounds right up my alley. Okay, so here's the maximum value on the interval of 1/2 R naught to R naught, which is why I didn't even write 0 over here, because it's not in the interval. Okay, so we want the maximum on the interval. So I'm going to plug in 1/2 R naught. Okay. I don't know how to compare R naught cubed to 2/3 R naught. Ah,
You plug that into the button. 2/3 R naught.
no. Stick it. Fine. Okay. So 2/3 R naught equals. Okay. Times 1/3 R naught times 4/9 R naught squared. That looks like a V. Which equals 4K over 27 R naught cubed. So really all we're doing is comparing 4/27 to 1/8. Old-fashioned way. 27, 32. That one's bigger. You ready for C? Okay. Ow, this is my favorite class. Yeah. Okay. Just leave that up just in case I needed any of that, which I probably did. Sketch the graph. I don't want to. Okay. On the interval 0 to R naught. R naught. Okay. So we know we have a point 1/2 R naught K over 8 R naught cubed. And we have the point R naught 4/27, 4K over 27 R naught cubed. And we have the point 0, 0. Favorite. How do you guys feel about it so far? I want to see what it is. Oh. Oops. 2/3 R naught is bigger. So here's 1/2 R naught. This one, where's my point? R naught 0, and then it was 2/3 R naught, and then 4K over 27 R naught cubed. So that's here. Does that make sense? Okay. Do you see my original mistake in writing that R naught 4K 27, but it was actually R naught 0. There it is. Questions? Does that make sense? Okay. Even though my explanation is not smooth and cohesive. Still make sense? Okay. Very good. Any other questions on the homework? Okay. So today, we're going to learn something pretty straightforward as well, called the mean value theorem. Yay! Yeah, this is barely anything. Okay. So, the mean value theorem states that, I think it's f of c. Yeah. F prime of c is equal to f of b minus f of a over b minus a. Which means if we have a function, okay, you have a point A, you have a point B, right here, that's f of A, that's f of B, and there's a secant line in between them. The slope of the secant line is represented by this change right here in y, which is, hey, what do you think of this? Color coding it. Solid. Over our change in x, which is b minus a. Okay, so the slope of our secant line here is just change in y over change in x, pretending it's straight. So what the mean value theorem states is that there is some number c in between where the slope of the derivative, or the slope of the tangent line there, is the same thing, so it's parallel. In other words, if we find the average rate of change in between any 2 points, there is some point in the middle of that interval that has that as an instantaneous rate of change. Which means, like, say you're driving and you're on the freeway, so you're doing 90, right? You guys are teenagers, I don't know. So,
I drive a big truck.
oh, you do? What kind?
Yeah, 2002 Toyota.
Oh, cool. I have a Tundra. I drive my car mostly, but I drove my husband's truck for like 4 years. So it's kind of like my truck. Because I changed the oil, not him. So anyways. Oh, okay. So say you are driving 60? 65. Okay, let's do 60 because it's easier to average out. All right, so if you pull on the freeway, like from a red light, so you go from 0 to 60, your average rate of change is 30, right? Ish, if you've gone 2 miles. So average rate of change is 30, which means at some point you were at 30 miles per hour in between the interval of 0 to 2 miles. Does that make sense? Or do you mean, is your hesitancy based on the fact that it makes a lot of sense, which is unnerving in some way?
Just trying to visualize the situation. Are you going from 0 and then at the very end of the 2 miles you hit 60, or you go from 0 and then in between the 2 miles you hit 60 and then keep going at a constant rate until you hit 2?
Well, if you did that, then you would have to be multiplying or dividing by, there'd be more 60s than there would be other things. So let's just say, for the sake of it, you're traveling at an average rate of change of 30 miles per hour. Okay, that means at some point instantaneously you were going 30 miles per hour. Does that eliminate the issues? What other issues are there? I will eliminate them.
Well, I don't know how to articulate it. Just keep going.
Okay. Well, there really isn't much more to it. We can take it and we can rewrite it as the change in y is equal to the derivative of this number times b minus a. And these are the two items that are in your book. Now there is a theorem that we passed over called Rolle's theorem, which just says that if, say you have this closed interval from a to b, okay? If f is continuous on this closed variable, which you can see that it is, and f is differentiable on the open interval, so only difference there is that it doesn't matter what's happening at a and b. If we can differentiate everything in between, it's fine. Okay? Then, and let's say this one kept coming around, okay, and got to here, and we called that b. So that this is f of b, which equals f of a. Rolle's theorem states, okay, well, if the function is continuous and that there's two y values that are the same for two different x values, that means there's some point where the slope of the tangent line is 0. So f prime of some number c is 0, which is very intuitive. Does that make sense? It had to have a turning point if it's going to hit the same y values, unless it's a constant function, which is also a possibility. Make sense? Okay, so the reason Rolle's theorem is introduced to you is because it is used in the proof for the mean value theorem. But I feel like the mean value theorem is very intuitive, and so if you want to see it proven, that's in the book for you. But I don't find that necessary to do any of the problems with it. Make sense? Okay. So the way you would use this . Oh. Don't be for tonight at 8. Ah! Okay, so sorry, I'm working until 9, I suppose, instead of just 8. Makes me happier. Did you guys see us throwing the logs on Monday? You really didn't notice us over here on this patch of grass throwing the log? Oh. You were sitting there.
I was watching YouTube.
All right. Okay. So, excuse me. Oh, I don't need to erase that. I can just write under it. Let's use a different color. I think I had a different pink. Yeah. Okay. So looking at example 3, says to illustrate the mean value theorem with a specific function, let's consider f of x equals x cubed minus x on the interval 0 to 2. Okay, and it wants to know does it want to know anything? F is polynomial is continuous and differentiable for all x. I guess this is just an example of it in action versus when to actually find something. So if this is true, and we're looking at it on the interval between 0 and 2, this will be true. So f of 2 minus f of 0 will be equal to f prime of some number c times 2 minus 0. So f of 2 just equals 8 minus 2, which is 6. F of 0 equals 0. So 6 equals 2 f prime of c. f prime of x is 3x squared minus 1. So f prime of c is 3c squared minus 1. So 6 equals 2 times 3c squared minus 1. 3 equals 3c squared minus 1. 4 equals 3c squared. C equals 2 rad 3 over 3 plus or minus. Does that make sense? And all that's really demonstrating is that at this value, in between 0 and 2, the secant line from 0 to 2. So you have the point 0, 0 and the point 2, 6. The slope of the secant line is the same thing of the slope at the point. It would have to be the positive one because it's in the interval 0 to 2. 2 rad 3 over 3. Does that make sense? Cool. Okay. Oh, example 4. Here we go. I'm just going to read it out loud for Sam. This one's for you, Sam. Okay. If an object moves in a straight line with a position function s equals f of t, then the average velocity in between t equals a and t equals b is f of b minus f of a over b minus a. And the velocity at t equals c is f prime of c. Thus, the mean value theorem tells us that at some time t equals c between a and b, the instantaneous velocity f prime of c is equal to that average velocity. For instance, if a car traveled 180 kilometers in 2 hours, then the speedometer must have read 90 kilometers per hour at least once. Okay. Does that make sense? Oh, good. Okay. So the main significance is that it enables us to obtain information about a function from the information about its derivative and the example of this principle. Okay. So chapter 3 is really just a lot of curve sketching. Does that make sense? The whole point of chapter 3 is to use the derivative and the second derivative and other theorems that you haven't learned yet to investigate how to graph anything by understanding the characteristics of it, what the derivative really means about the curve at that point, what the second derivative means is happening. It reminds me a lot of Algebra 2 when you're investigating polynomials and graphing rational expressions and things like that. So we also get to find the largest value that something can be. So, like suppose, this is example 5. Oh, I needed that. Whatever. Okay. So suppose that f of 0 equals negative 3 and f prime of x must be less than or equal to 5 for all values of x. How large can f of 2 possibly be? I just change that to a less than or equal to because we're looking for the largest it can be. Me step off camera and pull up my pants again. Okay. So we're just going to use this. So f of b, so we know that we're looking in the interval 0, 2. So f of b, we don't know, minus f of a, which is -3, equals f prime of c, which can at most be 5, times 2 minus 0. Well, let's put, must be at least then. So f of b plus 3 can at its greatest be 10. So at its greatest, f of b is 7. So the largest possible value for f of 2 is 7. Does that make sense? Good. So there's two other little corollaries they mention. I don't remember if you need to use them in the homework or not, so I'm just going to go over them anyway, but they're pretty straightforward once again. If f prime of x equals 0 for all x in the interval, then that means f is a constant function. If f prime of x is 0 for all x's, that looks like this. So of course it's a constant function. Because there's no change. Does that make sense? Okay. And then if f prime of x equals g of x, g prime of x, for all x in an interval, that means f minus g is a constant function, or is constant. And of course it is, because the derivatives are equal constantly. Does that make sense? Okay. That's it. Not so bad, right? I'm just looking at Avery for this one. Not so bad, right? Right. Stop looking for affirmation from Sam. It's not going to come. Okay. So the next unit, or section, no, I suppose, yeah, section 3.3 gets really into it as far as understanding how the derivative, what the derivative is talking about, or what you can imply based on that from the graph. But we're not going to do that until Monday. And then you're going to have really hard homework over Thanksgiving break. Yay! But for tonight, I mean, there aren't even really that many problems. That's it. Well, I would suggest that we watch Hot Rod because we're done. But Sid's not here. Avery's here. Way to go. And I don't want to get ahead in Hot Rod because Sid watches it. So that's it. Your homework's on Google Classroom. I guess we'll actually end early. Weird.